All right, so I think this is recording. Let's take a look at these three problems. They are quadratic equations. The directions tell us to solve these equations by factoring. So the technique that you were taught in Algebra 1 and Algebra 2 is the X method, and that's what we're going to do here. So first thing I look and notice that this is in standard form. There is no greatest common factor. So I'm ready in number 4 to just jump right in. At the bottom of the x, we put our middle term, negative 14x. At the top of the x, we multiply the first term times the last term. That's 40x squared. So we're looking for two numbers when multiplied together give us the top value, but when added give us the bottom. And it looks like negative 10x and negative 4x do the trick. So we put this information in the form of a table. Within the table, we fill in the diagonals. The one diagonal, we put the first term and last term of the original equation. Then the other diagonal, we put the values that we found in the x. And we factor these. We notice this diagonal both has negative numbers, so when we factor here out here, it's going to be negative. So let's pull out a negative 2 here, a negative 4 here, an x there, and a 5x here. So that allows us to rewrite this trinomial as a product of two binomials. And then we have a product theorem that says if you have a list of real numbers that multiply together to give you 0, then there's at least one 0 in the list. So it must be that either x minus 2 equals 0 or that 5x minus 4 is equal to 0. Since since these two factors have a product here that's equal to 0. So this gives us a solution of x equals 2. This gives us a solution, two-step equation, add 4 and divide by 5. So here's our two answers for problem 4. Take a look at problem 5. So it's not in standard form. So let's rewrite it. 3x squared minus 6x. Let's add 3 to each side. Plus 3 is equal to 0. Let's divide every term by 3. 3 divided by 3 is 1. Minus 2x plus 1 is equal to 0. With a leading coefficient of 1, it's a lot easier to factor. That you can do it with the x method, but you can also just look at it and see that x times x gets you x squared. 1 is a prime number, so negative 1 times negative 1 is positive 1, but they add up to negative 2. And this gives us a repeated solution, a repeated root of x equals 1. In a later skill packet, we'll talk about the graphs and the significance of having repeated roots. And if you have y equals 3x squared minus 6x plus 3, you should probably recognize the graph of that as a parabola that opens upward. When you set it equal to 0, that's finding the x-intercepts. So this is a parabola that opens upward, whose vertex is just touching the x-axis at 1, 0. And we'll look in that in detail in a later skill. So let's look at number 6 here. Again, it's a quadratic equation, but it's not in standard form. I like to have my leading coefficient be positive. So I'm going to move these terms to the right-hand side. I'm going to take away x squared from each side. 2x squared, take away x squared is going to leave me with x squared. Take away 7x from each side, and then I have plus 10. And again, with the leading coefficient of 1, if you want to keep consistent and you prefer to do the x method, that's fine. When you do that x method, here's what you should get. X minus 2 times x minus 5. And that splits into two equations. And normally I skip that step. Normally I just jump in and say that x equals 2 and x equals 5 are members of our solution set. So I hope that helps. Ask questions as needed, and I'll talk to you later. Bye.